Hey guys, let's go over this warm-up here. And it tells us to answer a bunch of these questions based off the graph, but I want to do something because I think it's a skill that you need or have been learning in Skills Practice 133, which is Key Characteristics of Polynomials, is that g of x there in green, I'm going to go ahead and graph that by hand. Although they gave me the graph, I want to review some skills. Remember, the one with the constant, the one without an x, this is called your y-intercept. So that is -3. Okay, the highest degree, notice how this is in order. They call this in descending order because the exponents, or the degrees of the polynomial, 4, 3, 2, 1, this is really an x to the 0 power, they're going down. Okay, so the highest degree is a 4th degree polynomial, and the easiest even that we know is x to the 2nd, right? 2 there is an even. Okay, what does that one look like? That one looks like starts up, ends up. So my arrows are something like this, okay? And then you have your, here is called the leading coefficient. That is a positive because there is no negative there. So that means these two red arrows here stay the same. Okay, so if I was sketching this, the 4th degree polynomial also tells you that there must be 4, let me get a different color here. This also means that there are up to, or maximum, a max of 4 zeros. Now again, zeros, or real zeros, are where they touch the x-axis here, okay? Alright, so let's go ahead and just do an estimate. I'm going to just go ahead and put some points, I think, maybe like here. So if I do a sketch that looks like this, let's change our colors. So if I do a bounce here, this would be 2 zeros. Let me explain why really quickly. The reason why this is 2 real zeros is because this, we talked about before, this is multiplicity. And when it does an multiplicity, we said it was an even, or if it does a kiss or a bounce. So that there represents 2. 1, 2. Okay? Now I need to come down to -3. Okay, since I did that, you have another 0 there, so that's 1 real. Let's try using 1 real. Why? Because it's a shoot through, we call it. When it goes through the x-axis, that represents just 1 0. So I have 1, 2, 3, and then I have to go up, back up on my roller coaster, going from left to right. I need to go back up to that red arrow, and what color haven't used yet? That one represents another real 0. Why? This represents our 4th one, because it is a shoot through. It's shooting through the x-axis. So if you count, you have 1, 2, 3, 4, and that 4 represents the degree of the polynomial. Okay, let's go ahead and answer all of these questions, okay? And my graph doesn't look exactly like the one there. Of course, the green graph is the most accurate because you're using a graphing calculator. How would you make it more accurate? You would make a table of values and basically input the x values and get these y values, and it can be a bit more accurate. But at least this was a rough sketch. Let's write that. Rough sketch. Okay, and so I just wanted to review how you could graph it. Okay, local minimums, so low points. We're looking for not the lowest point, but just low points. So I would say here and here. Now this one that I'm kind of emphasizing, that would be the absolute minimum. But if I just wanted, I can just say 2, -5. Now, this is a little bit difficult here. This is not interval notation here. Okay, this is just an order pair. And you can put the other one, -1, -8, which I think is the absolute minimum. Okay, what is a maximum? It is the highest, or local highs in the mountains, right? You're going from left to right, and right here in this green. So I don't know, 0.5, -1.5. Okay. Let's try a next one. Describe the domain. The domain is another words for the x values. And they're the x values. What x values does the graph have as you go from left to right? Okay, so x-axis, you can put -infinity to +infinity, and your graph has, remember the arrow, I like to do this with my highlighter, is that this left arrow here is basically saying the graph is coming from this direction. Does that make sense? And the right arrow is saying it's going into this direction. So we would say -infinity to +infinity. Now, always, and now this is interval notation. I'm going to write that IN. There's a difference. This is saying you could pick any number between negative numbers and positive numbers. Another way of saying this one is all real numbers. All real numbers. Okay, let's go to the next one. The range refers to the y values. So I'm going to write down here -infinity to +infinity. Okay, so the graph actually starts as you're going bottom to top. Let me write that. That's how I teach my students, bottom to the top. Okay, and as you go from the bottom, if you take your pencil and kind of lay it flat on the screen and go bottom to the top, you'll recognize that it starts there at -8. And then if you go up, let's see if I can do this with my highlighters. So you start here, and you keep going up. The last thing you're going to touch is those arrows. Those arrows are pointing to +infinity. Let me set off my graph. Okay, so anytime that you're using infinity, you're always going to use a parentheses, and the reason why is that you can never pick one particular point in positive infinity. You can never say, what's one big number you're thinking of? You can't just say like 10,000, right? Because there could be 10,001, so you can't include just one value. Now for -8, I'm actually going to put a bracket. The bracket says you're starting at -8 and you're including -8. Why is that the case? It's because if you look at this point here, although I made it solid or closed circle, every little point on the graph is actually a closed circle, which means you include that solution. Okay, where is the graph or roller coaster increasing? Increasing just goes from, another way of saying that is just kind of like small to big. And you're really referring to the y values. Let me use my highlighter. Where is the graph increasing? Okay, I would say as you go from left to right on the roller coaster, right, you're going down the roller coaster, you're going wee, and then you go up here, and you're going here. Okay, what's hard about increasing, simple idea but kind of confusing, is that you're starting at the x values. The x values, and I'm going to highlight those here. So it is increasing from -1 to about 0.5. And that 0.5, you notice you use that number. Now, why did I use parentheses and not a bracket. Because I say at -1, at that point that has blue and black and the red line through it, it's not increasing or decreasing at that time. It's the low point. Okay, now you're going to put something called a U, or union, because it basically says you have two answers here, or multiple answers. Then I go from 2 to infinity, right? That was the other yellow highlighted. Okay, erase that. Okay, then you're at, well, I guess we can use those. Where is it now decreasing? Where is it going from? My definition here would be a big number to a small number. Or if you think about a positive to a negative or something like that. Well, here is a down part of the roller coaster, and here's the down part of the roller coaster. So to write that, I would go -infinity to about -1. And if you think about this, I'll try to show you guys later, -1, and then union from 0.5 to 2. And let me show you guys some magic as a visual. Okay, if you think about up to that, from the left side to the red line, is -infinity to -1. And then that yellow patch, what is the yellow patch? Well, that's really just -1 to -0.5. This yellow part right here is where it's increasing, that yellow part. And then the green part, where it's decreasing, 0.5 to 2, well, that's right here. And then the last part where it's increasing is from 2, this last yellow part is 2 to infinity. So those are the parts where it's increasing and decreasing. Okay. Let's move on. What do we got next? Okay. This one is a little bit confusing. This one is actually in behavior. In behavior. Okay, so I'm going to write it like we've done in the class. As x approaches, okay, this one is saying decreasing. So they're saying as it goes towards -infinity, and this one's saying as x approaches +infinity, what happens to the graph? Okay, remember, as x approaches -infinity or decreases, this is going towards the left. Okay, as you go towards the left, running out of colors, and it's getting really crazy in here, so let's try to erase some things that we absolutely don't need. I guess keep that one. What happens as you go towards the left? What happens to the graph? Look at the last arrow, just kind of right here. Is it going up or down? It is going up on the f of x, or the y values. How do you say up? Well, that would be, or this is the y-axis, this up would be saying +infinity. Okay, number 8, 5. How is that 8? That's 5 plus 3. It's to the right of the V, Roman numerals. So this one is saying as you go towards the right, towards +infinity, what's happening to the graph? Where's the graph finishing? The graph is finishing up. So that would also be +infinity. We just write +infinity, but I'm writing the word up to help you understand. Okay, something I want to note is notice that these are the same. They're both finishing up, and that refers to the arrows. So when you see an even degree polynomial, you're always going to have here the same. It just depends on your leading coefficient. If it's an odd degree, like x to the third, then you're going to have, those are going to be opposites, okay? One's going to be positive, one's going to be negative. All right, almost done here. Number 9, x is 10, and this is 1 before it, so you kind of subtract 1. Negative 1 plus 10 is 9, so that says 9. Determine the x-intercepts. Where does it cross the x-axis? Well, it crosses the x-axis here and here. So it's best, again, to say that it is a order pair. So I'm going to say negative, I don't know, 1.8 comma 0 and 2.5 comma 0. So all of these, let's make sure that they're highlighted here. Whoops. All of these here are integral notation. And everything else is an order pair. Okay, where is the y-intercept? Where it crosses the y-axis? Cross the y-axis. So that would be this part right here, going up and down. Well, the graph only crosses it once. And remember, we already have that. That's at this point. So that would be an order pair 0, negative 3. Okay? So this was a summary of everything we've been learning for the past 3 weeks. Key characteristics of polynomial functions. This is our roller coaster. This is a good way to promote the project if you choose to do it. It's best to kind of like pick something that you can graph, right? Like maybe it's your number of clicks on your, when you play your video game on your computer over time. Let me just put that. And so that might make clicks, number of clicks, and no. This other way. Time, and then your number of clicks, right? And so at the beginning of the game, click, and then you do all these like crazy clicks, and then there's a low point in the game, and it looks like something like that, right? And then based off of this graph here, then you can use all of our vocab words that you need. And why is that important? Like, well, when I have a bunch of clicks, I need to set up my towers for defense or something like that. Okay? Good luck, guys.